right, now I've got my major chunks that I need. So I know what my sum of squares within is, and I know what my sum of squares between is, and I want to compare them. All right, and so we go back to that sort of basic idea where that I already mentioned, where I've got the between divided by the within, and so I'm going to get to that in just a second. But first, I got to divide them by their degrees of freedom. Do you remember that? What's the degrees of freedom within? Well, that has to do with how many I have in the group, right? How many I have in the group. And so the way I calculate that is the total n, I've got the total, then I'm going to subtract out the number of groups I have, and then that's going to give me the degrees of freedom for the within. Okay, so that's, in this case, there's 27 altogether, and then there's 3 groups, and so that means 24 is my degrees of freedom within. Okay, degrees of freedom between, that has to do with how many groups I have. Okay, so I'm starting off with my number of groups, which is k, and I'm going to take out 1. Okay, minus 1. And so in this case, that's 3 groups minus 1, and that equals 2. So then I've got 2 degrees of freedom for the between. Okay? All right, we're almost there. We're going to calculate what are called the top part, what are called the top part and the bottom part. That's what I call them. The top part and the bottom part of the F statistic, which is the between and the within. But we're going to, those actually have a name. They're called the mean square. The mean square. Okay, so we have the mean square within and the mean square between. Okay, the mean square within is simply the sum of squares within divided by the degrees of freedom within. That's simple. Okay, we already got that stuff. And then the mean square between is the sum of squares between and the degrees of freedom between. Very, very simple. Okay? All right, so it turns out that the mean square within equals, what does it equal? Sum of squares within. So 3,776.51 divided by its degrees of freedom. Degrees of freedom within is right here, 24. And that turns out to be, if I calculate it out in my calculator, 157.36. Okay. And then the mean square between equals the sum of squares between 240.82. We already calculated that before. Whoops. 240.82 divided by its degrees of freedom, which we have right here, degrees of freedom between, and that was 2, we calculated, 2. And so that equals 120.41. All right, and we're almost done now. We've got our top part, and we've got our bottom part, and we just got to put them in to give us F. Where can I squeeze that in my board? Let's do it right up here. Then it'll be at the top. Okay, so the F is the mean square between divided by the mean square within. All right, and all we do there is just plug these numbers in. Between is 120.41, and the bottom is 157.36, and that equals like 0.77, I think. Yes. 0.77. That's our F statistic, 0.77. Okay? So between is pretty low compared to within. Okay? There's a lot of within variation in my data, but the variation between these groups really isn't that big compared to how much variation there was in between. And if you think about that, you can see it. The top here is 72 point something, and the bottom is 65, okay? So there's only, from the very top to the very bottom of the means, it's only about 7 points. In fact, it's exactly 7 points, okay? But if you remember in our data, it went from like 56 to 92 or something like that. That's a lot more variation than we're seeing right here. So this between variation is pretty small compared to within, and so we're ending up with an F statistic that's small it's less than 1 because the top is smaller than the bottom. We ended up with a fraction, just like I said. And I said whenever f is below 1, it's not going to be significant. I can just tell you. We don't really need to go to the table. But let's go to the table just so we can show you how the table works. Okay?